So exercise 2.3 question is, you are given relations and you are asked to check whether it is a function or not. So let me call the first one as f, for example. It is given a set of ordered pairs 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, and 17, 1. So here every member has unique ordered pair. You can see with 2 there is only one ordered pair, with 5 there is only one ordered pair, with 8 there is only one ordered pair, with 11 only one ordered pair, 14 and 17. So every member has unique image here. So f is a function, not only relation but it's a function. And domain will be all elements which are at the first place. So 2, 5, 8, 11, 14 and 17. And range would be second members 1, 1, 1, 1, 1. So it is this much only. So you can see that it is a constant function. It is a constant function. Recall the type of functions. Constant function, because your range is a singleton set. Every member of the domain goes to just one member 1. So this is called a constant function here, like this. Okay, second one you will try. We'll go to third one. Let me call this as, for example, G here, relation G, 1, 3, 1, 5. So once you write these two things, you must have realized one has two different images. Here, this member 1 goes to with this 2, 3 and 5. So this is here f. You can say that the G of 1 is 3, G of 1 is 5, for example. So 1 has two different associated elements, associated members. So therefore it is not a function. It's just a relation. It's not a function, it is just a relation. One has two different images as I shown here. This is not possible in a function. This is just a relation. Question number 2, second question. You are asked to find domain and range, both the things, but here function is in form of formula. So first function is fx equals to minus modulus x. Now domain means here find possible values of x which you can choose. Domain means possible values of x. So here you can take any value of x as a real number. So here any real value of x will do. So therefore you can say that the domain is all real numbers. Domain equals to all real numbers R. That's a domain. Meaning of domain is you get possible values of x for which this function is defined. You know modulus is defined for any real number x. You already studied. So that's the domain. Now next question is range. Range means values of function. Range means values of function. Values of function fx. That's called the range. So here you know, for every, this is read as for every x belongs to R, modulus x is always greater than or equal to 0. If you find modulus of any number, it is always greater than or equal to 0. So if I multiply, I need minus here. So if I multiply with minus sign, you know, inequality get reversed. This is very basic property. If you multiply inequality by a negative number, the inequality will be reversed here. So you have this. Now what is this? This is a function fx. So fx is less than or equal to 0. This is 0. All these numbers less than or equal to 0. These numbers. These are the possible values of fx, which is called range. So range would be all possible numbers from left side of 0 including 0. So 0 and it goes to here minus infinity. Usually at minus infinity and plus infinity we write open, this is closed. So every number less than 0, that is this portion, this is the range of the function. This means values of the function, if I take any member from the domain and if I put into the function, my answer will be, that is the value of the function will be from minus infinity to 0, that is left side of 0, this numbers. So we can write this way. Question number 2, if I choose this, root of 9 minus x square. Now first domain, you know, domain means function should be defined. Now you know you have inside the square root. So if you recall, inside the square root you must have positive number. So here fx is defined, I mean possible, defined if inside the square root you must have number greater than 0 or 0. Remember, if this number is negative, for example, if I take x equals to 4 here, then root of 9 minus 16. So this is root of 9 minus 7. You know that this is not possible. Inside the square root you cannot have negative number. So root of something is possible only when that inner number is 0 or more than 0. Take x square on the other side. So we have this. That is, you can say that x square is less than or equal to 9. So you can say that x must be between minus 3 and 3. So here domain will be close interval. You recall sets. This means close interval minus 3 to 3. This is the domain. Again recall, domain means possible values of x. So here what are the possible values of x for which function is defined? That is minus 3 to 3. If I take any number from minus 3 to 3, then this inner number would be always positive. You check, if I take any number beyond 3 or less than minus 3, then this will not be negative. So inner number should be greater than or equal to 0. 9 minus x square should be greater than or equal to 0. So domain is this. You cannot take number outside this, remember, for function. Now I'll go to range here. Range means values of the function. Values of fx. Now domain you know. So if I take any number from minus 3 to 3 and if I put here, now being a square root, my answer will be always positive. And here if I take, for example, let's take 3, then 9 minus 9 gives you 0. If I take 0 here, then this is maximum 9. So here you can see that this will not go beyond 3, and it is always greater than or equal to 0. The root of 9 minus x square is always greater than or equal to 0 and less than or equal to 3. You take any number from this. Suppose if I put 0, then maximum it is 9 minus 0, that is 9, so 3. So you can, this is fx. So therefore range of the function would be close interval 0 to 3, starting from 0 to 3. You take any number from this, you put into the function, you will get the number from 0 to 3 only. This is called the range of the function, remember, and this is the domain. This is a good question. So I'll go to fourth question. Third is too simple. You are given one function here, function t, which maps the temperature in degree and Celsius in temperature into degree Fahrenheit. So there's a relation you might be knowing. Now, for example, if you want to find t of 0, then it's very simple. You put here c equals to 0. T of 0 means c is 0. So 0 plus 32. So here value is 32. Now go to fourth question directly, fourth sub question. We want to find the value of c. This is the question. And what is given? T of c equals to 212. Now what is the formula for T of c? That is here 9c by 5 plus 32 equals to 212. Now take 32 on the other side. So 212 minus 32. And you simplify further, so you'll get the value of c. This much you can do. Question number 5, which is again important question. There in each question we find range. We find range, that is values of fx. Range means possible values of fx. That's called range. So if I go to third question first here, there fx equals to x, and here x is a real number, that is x belongs to R. This means it comes from the domain. This is indirectly domain given to you. Now if you recall, this is a linear function and domain is R. So here for every x belongs to R, the image is itself. So this is indirectly identity function, if you recall. This is indirectly identity function, if you remember first type. So for every x, the image will be itself. If I put 1 here, 1. If I put 2 here, 2. If I put 1 by 2, 1 by 2. Like this. If I put 0, it is 0. If I put 1 here, 1. If I put minus 1 by 2, your answer will be minus 1 by 2. If I put root 2, it would be root 2. So you'll get every number here, because here you can choose every number. This would be every number here, every real number. So what are the possible values of the function? That is R. So range would be R here. Range will be all real numbers, because here you can choose any real number. I can take 100 also, so 100. I can take 3 by 4 also, so 3 by 4. I can take 1 by 100, so you'll get 1 by 100. So these values, that is fx value, would be every real number, not only integer. So range will be again all real numbers, R. Now next question is fx x square plus 2. This is a quadratic function, you know. We want just range. What's the domain? All real numbers. Your domain is all real numbers. Now go back to this. You know, square of any number is always greater than or equal to 0 for every x belongs to R. We know this much. For every real number, square is always greater than or equal to 0. You add 2, because I need x square plus 2. So x square plus 2 is greater than or equal to 2. Adding 2 on both the sides. Adding 2. Now what is this? This is a function. So function is greater than or equal to 2. So if this is, for example, 2, then the value of the function is 2 or more than 2. That is this portion. Starting from 2 to this numbers. So range would be, you can say that possible values of fx, that is 2 to, it goes to infinity. So plus infinity. This is the range. Range of the function, that is 2 to infinity. first question, fx equals to 2 minus 3x. But here you are given that x belongs to R with this condition, x is less than 0. Recall, here it was just x belongs to R. So domain is any real number. Your domain is only negative real number, less than 0, remember. So we start with this. Here we started with every number. So as means this is given to you. X less than 0. As means this is given. Now you need minus 3x here. So multiplying with minus sign. Minus 3x. You know, if you multiply with negative number, inequality get reversed. So this less than becomes greater than. And minus 3 into 0 is 0. I repeat, x is negative. From where I have chosen, this is given in the question. Multiplying with minus sign. When you multiply with minus sign, less than become greater than. Now I need 2, so adding 2. So 2 minus 3x is greater than 2, adding 2 on both the sides. Adding 2 on both the sides. 0 plus 2 gives you 2, minus 3 into 0 gives you this. Now what is this? This is a function which is greater than 2. This is just a function. So here you can say that the value of the function, if this is 2, then more than 2. Remember, here it was greater than or equal to 2. Here just greater than 2. So range would be here. Range would be open interval 2 to it goes to infinity. So infinity. This is the range of the function. Now in this question, if I drop this condition, if just you are given, if just x belongs to R, if you are given, then what is the range? This is the question now. Suppose you are given just x belongs to R. If I drop this condition, then what will be the range of this function? You know it. Try to answer this. Now if you are given x greater than 0, here I have chosen x less than 0. If x is greater than 0 here, then if I come to this, if I multiply with minus sign, then minus 3x will be less than 0. Because this is positive, I'm multiplying with negative numbers. So greater than, so I'll write x here, let me write greater than 0. So if I multiply with minus sign, then inequality will be reversed. If I add 2 here, then less than 2. So this is a function. Function is less than 2. Value of the function is less than 2. So what will be your range in this case? It will be from minus infinity to 2, remember. So here less than 2. This is for greater than 0. You think if it is belongs to R, then what will be your range? Here it is less than 0. In that case 2 to infinity. Next small point is, it is about addition, subtraction, multiplication and division of two real functions. This is sometimes called algebra of real functions. So we start with two real functions. Let f be a function from x to real numbers. Real function means codomain should be R. Another function g, domain and codomain, here I have chosen equal as per textbook, not necessary always. So f is a function from x to R. This is a domain. X means any non-empty set. It can be any set. Domain can be any set. But codomain should be real number always. Then first one, the addition, which is very simple. So addition will be f plus g. It will be a function from same codomain to all real numbers. And f plus g at x will be, you find fx, find gx, and then you add them. This is addition. This is true for every x, remember. For every x. Next one, that's called here subtraction. So subtraction of two functions. that is f minus g. It will be a function from x to r. F minus g at x will be fx minus gx. It's like addition only for every x. You find fx, find gx and do their subtraction. This is the subtraction. Multiplication like these only. Multiplication of two functions. So it will be f into g from x to r. Same domain, same codomain. It's from x to all real numbers. And f into g at x. So you find fx, find gx and multiply them. So this is your answer. F of x into g of x. This is not into, remember, here this is read as of. So you apply f on this, apply g on this and get the product. This is the multiplication. For the division, we need to be little careful. Division, there is a function from f by g. Your domain is x, codomain is all real numbers, and f by g at x, it would be obviously fx upon gx. So find value of f at x, find the value of g at x, and then take the ratio. Now when you do this, you know that this division number should be non-zero. If you have, for example, 2 by 0 like this, then this is not defined. You know this. So what you have to do, from this, you drop all x for which gx becomes 0. So minus all x for which gx becomes 0. I repeat what I did here. Domain of this is x minus, you drop all x for which denominator function becomes 0. Because if there is any x for which this becomes 0, then this will be undefined. Definition is same like multiplication, subtraction and addition. But there is a little correction in the domain. Here for multiplication, in case if this is 0, no problem. Something into 0 gives you 0. Here if it is 0, not an issue. If this is 0, not an issue. But in denominator, if this turns out to be 0, then this create a problem. So what we do, we find all x for which this becomes 0 and we drop from the domain. So when you find division, you need to be little careful. So this is about these 4 functions. Let me take a simple example, you will realize. So we'll start with 2 functions here. Function f from r to r, fx equals to 4x. Another function from r to r, x square minus 1. The question is, you find all these functions. Find f plus g, f minus g, f into g and f by g. This is the question. Division, multiplication, subtraction and addition. So first one, that is f plus g. So obviously it will be function from same domain to same codomain. So r to r. And f plus g at x, you know the formula for this is fx plus gx. This much you know. Now what is fx? It is just 4x. So write 4x here. Plus what is gx? That is x square minus 1. So this is your function. Finished. F plus g at x will be this much only. 4x plus x square minus 1. If I go to f minus g, so it will be function from r to r, real numbers to real numbers. What is f minus g at x? It is, as you know, here fx minus gx. F of x minus g of x. What is fx? 4x. What is gx? X square minus 1. So finally you will get the 4x minus x square plus 1. This is your function. Now next, f into g. It would be again a function from r to r. What is f into g at x? It would be fx into gx. What is fx? It is 4x. What is x gx? X square minus 1. You can leave like this. If you want, you can open the bracket. You can write like this also, 4x cube minus 4x. This also correct. So f into g at x is this. Next, I'll go to f by g from R to R. That is f by g at x. It will be fx upon gx. Now here you know fx is 4x. What is gx? X square minus 1. Now you see, is there any value of x for which x square minus 1 becomes 0? That is yes, you know, here minus 1 and plus 1. So we need to drop these two numbers from the domain. So here, I'm sorry, let me rewrite like this. So here f by g will be a function from r minus numbers for which this becomes 0. That is minus 1 and plus 1 to r. And then it is this function finally. So f by g at x will be finally 4x upon x square minus 1. You cannot choose 1 in the domain. If I choose 1 here, then 4 by 0, which is not possible. If I choose minus 1 in the domain, then again 4 by 0, which is not possible. So here, what you did, you have dropped minus 1 and 1 from the domain of the function for which it became 0. So this is the domain of the division of the two functions. When you define division, you need to be careful. For multiplication, subtraction and addition, it is just the common domain of the given two functions. I'll take one more example where functions are in form of ordered pairs here. F is a function from 1 to 2, 3 to r, and the other one is from this to r. So here domain is a set having 3 members, 1, 2, 3, 1, 2, 3. Functions are given in form of ordered pairs. You know, f of 1 is 2, f of 2 is 3, f of 3 is 4, g of 1 is 0, g of 2 is 1, and g of 3 is 2. The question is, let's find f plus g, f minus g, f into g, and f by g. Let's see this. So here all will be for f plus or minus g and f into g at least. Domain will be 1, 2, 3, 2 real numbers for all these functions. This is so simple. For these 3 functions, plus, minus, and into, domain will be the common domain 1, 2, 3, 2, all real numbers. Now what is f plus g here? That's the question. So you know f plus g here at 1, domain has 3 members. So it is f of 1 plus g of 1. What is f of 1? 2. What is g of 1? 0. So 2 plus 0, which is 2. F plus g at next member in the domain 2. So it is f of 2 plus g of 2. What is f of 2? 3. What is g of 2? 1. So here it is 4. F plus g at f into g, let's find f plus g, at 3. Third member in the domain. So f plus g, 3 plus g of 3. What is f of 3? 4. What is g of 3? 2. So here it is 6. So here in this case, if I write in form of ordered pair, f plus g, 1 connected with 2, so 1 comma 2. 2 connected with 4, so 2 comma 4. 3 connected with 6, so 3 comma 6. This way you can get f plus g. Similarly, you can do f minus g, f into g also. I want to go for f by g. Now for f by g here, you know f by g at x is fx upon gx. So the first question is, do you have any x for which gx becomes 0? Yes, which is 0. So you cannot take 1 in the domain. So what is the domain here? Common domain minus 1. So domain will be just 2 comma 3, remember. 2r. And you know definition is this. I repeat what I did. Get all x for which gx become 0. You know where the gx becomes 0? If x is 1. If x is 1, you look at it this. If x is 1, the value of the function is 0 here. So this 1 you need to drop from this common domain 1, 2, 3 or this one. So you are just left with 2 and 3. So here you will be having just two ordered pairs. F by g at 2, which is f of 2 upon g of 2. What is f of 2? You know 3. What is g of 2? You know 1. So this is just 3. Next, if I go for f by g at 3, so it is f of 3 upon g of 3. What is f of 3? You know 4. What is g of 3? You know 2. F of 3, 4, this is 2. So your answer will be 2. So if I write in form of ordered pair, f by g, 2, 3, 2, 3, and the other one is 3, this one 2. Only two ordered pairs because 2 and 3 are only members of the domain.